Eric, how's it going?
I'm doing good. How about you?
I'm doing pretty good. What can I do for you?
I've been working on my calc homework and I'm having trouble with integrals.
Okay. How do you feel about integrals?
I vaguely remember the teacher calling them anti-derivatives, but that's pretty much it.
Okay, that's a okay starting point to start with. How do you feel about taking derivatives?
I have derivatives down. I feel comfortable doing them using the power rule, product rule, and chain rule.
That's excellent. So let's start by looking at basic power rule derivative, and we'll move on from there.
All right, sounds good.
So in order to understand integrals, Eric, let's start by looking at a power function derivative. What would be the derivative of x squared?
That'd be 2x to the first.
Okay. So if this is equal to 2x to the first, then we need to create like a rough formula for how you got that in order to understand integrals.
Okay.
So the rough formula for that would be we took and minus the power by 1. So if we started with x to the nth, the rough formula to get a derivative would be x to the n minus 1. And we also brought it down and multiplied it to the front. So that n comes down to the front here, just like that. So this is our rough formula for a derivative. An integral, also known as an antiderivative, is just like it sounds. You're just going backwards. So we need to create a formula that's basically a reverse of this one.
Okay.
So let's take a look at, let's say, if we started with x to the n. So this is part of the notation for integrals, this s right here.
Okay.
You're not actually going to do a lot with it. Later on, it'll have bounds attached to it. You'll see it down here and up there. But your teacher will cover that in class. And then on the end here, you're going to have a dx. And that just stands for respect to x. So if you had like a y in here, you could not do the problem. It needs to match. If you had a y there, you'd have a dy.
Okay.
Alright. So to actually take the integral, we want to do the reverse of this. So instead of dropping the power by 1, what we're going to end up with is raising the power by 1. So n plus 1. But as you remember before, we also brought the n down to the front right here and multiplied it. So in order to do the reverse of multiplication, we're going to divide by our new power. Our new power is n plus 1. So we'll draw a line like that and put it in the denominator.
All right.
So this is our rough formula for an integral. But it's missing one last thing. So if we took a derivative, but say on the end of it there was a constant, like a plus 1 per se, when we took the derivative, it's still the same derivative because the constant disappears, drops out. So in order to factor that possibility in when we're taking an integral, we're going to add a constant to the end. We're just going to use c plus c.
Okay.
Excellent. So now you have a rough idea of how the formula works. Let's apply it to an actual problem.
Okay.
So in order to attempt this integral, let's first write down our formula for our base integral. So we have integral x to the nth dx, and that's going to be equal to x to the n plus 1 over n plus 1 plus c. Okay, so now we can see our formula and we see our problem. Let's give it a shot. So from here, we're going to keep the 3 the same. We're going to put our x in. And now what's our new power going to be, applying this formula to it?
It's going to be n x to the 3.
X to the third, yep. And then we got to divide by the same thing, right? We see the n plus 1 up here, so it's going to be the same value that we're dividing by. So we'll put a 3 down here. And then these 3's can now cancel.
But not the exponent 3.
Not the exponent 3. That one won't cancel. If you had an x to the third down below, you could cancel it, but that would be a different problem. So our answer is going to look like x to the third. And are we missing anything?
Can't forget the c.
Exactly. Can't forget that c on there. So does that seem to make sense? Is there anything?
Yeah, that clears up a lot. It makes it a lot easier. Thank you.
Awesome. You go ahead and give those practice problems a few tries, and I'll come back in a minute.
All right, sounds good. Thank you.
How's it going? Are those practice problems going well?
Yeah, they're doing great. I just don't know what to do with the dx at the end of the problem.
That's a really good question, Eric. So once you've taken the power and raised it by 1 and then divided by that new power, you can just drop the dx out of the problem along with that first s looking integral sign.
Okay.
Any other questions?
I think that does it. Thank you very much.
Great. The student's learning goal was to learn how to take a simple integral. In order to assess their current knowledge, I asked questions to see how they felt with integrals and derivatives. From his answers, I could tell he was confident with derivative skills, but had no real knowledge of integrals. In order to have him understand integrals a little better, I helped him derive a general formula to solve one. Once we had the general formula, I walked through a practice problem with him so he could have a fresh example before he attempted any by himself. I implemented growth mindset by encouraging questions and keeping a positive attitude throughout. I used scaffolding by doing a problem with the tutee and then giving him practice problems to attempt on his own.